Hello and welcome to the fun part of this class finally, week 12 SQL. Hopefully all the mind tap work is behind us and the rest of this course is just downhill. It's fun learning, it's less Excel. I know there's a lot of Excel, a lot of crazy things, and that's just the nature of this course. But now we move to more practical, everyday, useful things. SQL is one of them. In a professional academic sense, I've been teaching SQL for a couple years now. I teach in every one of my classes. I think it's one of the most important things you can learn, okay? And every time I revise this, every semester I revise this particular lecture, I get better at it, and it also takes me a lot longer to revise it because I really want to hone in on what's important to learn SQL and databases. Because it's hard, once you really start learning SQL, people do one thing all day. And it's hard to teach SQL to such a broad topic. How would you teach Mandarin? How would you teach Spanish in 1 hour? Because you also have to teach culture too. So this course is going to be, or this lecture is going to be broken into two parts: the conceptual part, which is this, and then the action part, which I'll go into after this video. I'll stop this video. I don't want this to really go more than 45 minutes to an hour. I'll do my other video, my action part, as I call it, where we actually dig into SQL. I used to have these in one one lecture. Now I'm kind of breaking it up into two because I really want you to dig into this. So, SQL. You can't learn SQL by just reading about it, or, here's a book on SQL. Let me switch my screen, iPad. Yeah, it's a great book. It's one of the books I've used. But I'll tell you this right now. If you're hoping to really get good at SQL by reading, it's not going to happen. You have to do. Now, you can get an online server for SQL and start playing with it, upload data set from Kaggle, and really start playing with it. So that's my #1 recommendation, okay? You can try learning Spanish from a book, but if you never practice it, it's just not going to work. Same thing with SQL. Find something you're interested in, find something you're passionate about, or do something that you can tolerate enough that you really want to take to the next level. And just start playing with SQL. How do I get this? How do I answer this? How do I do that? I like to analyze me assignments. Now, SQL is a great starter language. It's probably one of the best starter languages there is. One of the reasons it's such a strong starter language, at least in my opinion, is that it's kind of loosey-goosey. And I don't know any other good way to say that, but it's not real particular on capitals. It's not real particular on tabs. It's not, it's really kind of relaxed on the semantics and the context of the words. And also it's very easy to use. It's basically, in this class I'm bringing it down to 3 parts. There's 3 parts and you're good to go. Where Python or Ruby or C, they become much more complex much quickly. But SQL, the average individual can write good SQL statements in a few days. Okay? Another important part too is that SQL teaches you, I don't want to say to be humble, but if you have a problem, it's not the computer's problem, it's your problem. You're not asking for the right information. You're not interacting with the computer right. Okay? So it teaches us how to debug, how to Google correctly, which I know sounds crazy. It teaches us how to Google correctly, how to debug, and how to really think about what we're asking for. If I ask ChatGPT the wrong question, guess what? I'm going to get the wrong answer. But if I ask it the right question, I have a lot higher chance of getting the right answer. And remember, throughout this class, I've talked about, hey, data is the new gold. Well, if you can access that data, if you can request that data yourself using SQL, you're basically mining gold. Where if you have to rely on other people, well, then you're at their mercy. If they're running behind, they call in sick, they're out on vacation for a week, guess what? You wait a week until they get back, or 2 weeks. So if you have that power, if you have that freedom, even if you're not very good at it, you can at least start requesting that data yourself. So it's a super important, super valuable tool. So remember, this week we have a discussion. I'm going to go over a couple of these things. Leak code. I've never taught this before, but I'm trying a little different approach. I want to give you real-world problems and kind of real-world solutions. SQL is a great site to learn SQL. So I recommend both these. I'll have this video which just goes into the conceptual parts of SQL. And I have a part 2 that goes into action, like, hey, this is how we do this. I'll show you real SQL examples, very simple. And then a Notebook LM video, because a Notebook LM is Google's kind of, I don't know, it's half between Apple Notes and Evernote and a bunch of other products. You just kind of upload your notes and it can quiz you on it. It can transcribe, it can make bullet points. It's a really interesting product. And I have no idea how long it's going to last or if, the future of it, but while it's here, I think it can benefit a lot of us students and learners, lifelong learners. So let's dig in. So how did we get here? Okay, it's a fair question. In 1950s, let's say, and there's people that did this, they would record the weather every day or every hour in a notebook. They just got a pen and paper and they wrote down, I don't know if you can see hey, today's weather is 86 degrees. Tomorrow's weather, or yesterday's weather was 96. They just wrote it down on a pen and paper. Well, now, we can have weather stations that record weather every second. So in the course of 2 or 3 minutes, I can have more data than weather stations have ever been around. Okay? And that's just one example. We are capturing more information quicker and arguably more accurately than ever. Your phone records through, or maybe not your phone, well, I guess your phone does, and also AT&T or Verizon or T-Mobile, they know where your phone is all the time through 3 different cell towers, maybe 4 or 5. They have to triangulate it. We have to talk to it and see what ones are stronger links. So every phone is, receiving multiple cell signals, recording that information, and doing much more. I mean, just think about what are the, 2 million, 5 million phones in Vegas? Every second, you're getting 10 or 15 location recordings. And just think about the amount of data since I've started talking in the last 7 minutes. It's a lot of data. Think about Reddit. I mean, in the past, there was no way that we could all just go down and pick a topic and write and pick a topic and write. It would be too cumbersome. Now, you can post a topic and boom, thousands of comments in a day. So we get this larger and larger data exponentially almost. And somehow we have to either organize it, access it, things like this. So that's kind of where all the data comes in. It's a ton of data. So now we have a couple different big terms, OLTP and OLAP. Okay, so OLTP is a transactional processing database. Okay, and these are more general ideas. You have a car and you have a truck. Well, an SUV is kind of both. A minivan, maybe it's kind of both. And my truck has 3 rows of seating, a minivan has 3 rows of seating. A truck has 4-wheel drive, a car has 2. See, nothing's really cut and dry, so just always kind of remember that. But anyway, so transactional processing database, its focus, okay, is to record like basically incoming data. So maybe a cash register, okay, maybe some type of EMR that records doctor's notes. Maybe some type of FedEx system where they scan your package or UPS and they have the little phone boom. And they scan your package or you sign for it, okay? All those are production databases. And they're designed to store that data and then basically move it somewhere else eventually. Now, there's an online analytical processing database, an AP. Now, that is designed to do reporting. That's something that analysts or nerds basically access to pull data. Now, why don't I want to analyze or pull data from my production database? I mean, my data is a little bit fresher. What is the harm of me pulling data right from my production database? Well, what if I do some type of function and it locks that machine up, that locks that database up? Well, then I have no ability to make money. If I'm a race car driver, am I going to take my race car, am I going to drive it home, and then is that my daily driver? No. And that's how I make my money. So as a race car driver, I have my race car, and then I also have my daily driver, or the car I drive home with. Because if I mess up my race car, I can't make no money. I'm out of business. If I mess up my transactional processing by doing a bad query, by accidentally deleting it all, by whatever reason I have a problem, then I'm out of business. And you'll see that you know, there's times where databases go down and companies basically are offline. Yeah, so that's why a lot of times they're aggregated up. I've got a visual I'll show you on that. They're aggregated up to a data mart, a data lake, a data warehouse, one of these terms, so we can do reporting off it. Your phone, so their contacts is a database. So if somebody calls me, but for some reason my contacts is not working and it stops the phone function from working, now my phone is no longer a phone. Okay, so ETL. Now, most traditional definitions of ETL is extract, transform, and load. And what that means is like, hey, I'm going from transactional processing, a production database near the customer, near the data, and I'm uploading it to some other source. But in my mind, an ETL is also you downloading something, putting it in Excel, doing a sum, and sending it over to Power BI or Tableau, making a report from it. You have the data, you want to extract it from SQL, from something. You want to transform it, do a sum, do a divide, get rid of nulls, and then load it. Do something with it. Okay? I used to go more the history of SQL, but really, when you think about SQL, all it is basically an Excel file, a bunch of Excel documents. If you have 2 or 3 Excel documents, how do you merge them together? That's all a database is, rows and columns, same basic idea. There are differences in types of SQL. So again, don't get frustrated with that. What do I mean by that? So lately, well, let me start. When I first started, I used MySQL, the very last one right here. I used MySQL. Okay, even my mouse doesn't show up. But then I moved to Microsoft SQL, which is TSQL. And now I'm using Snowflake SQL, which is a slightly different version of SQL. Okay. Now, the core fundamental idea is the same. The code mostly is the same. But sometimes there's slight accent differences. So the way you might limit something, the way you might filter something is slightly different. Okay. But at the end of the day, all the major functions basically work the same way. In theory, I could go down to the deep south and still be able to communicate and articulate with people. I'd still be able to go up to Canada.
I understand. Is there something else I can help with?
I could go to Canada and still talk to Canadians that spoke English. So again, they have slightly different dialects and they say things differently, but I'd be able to communicate with them. Okay, so major SQL terms. A database, and it's easier once you kind of see it, to be honest with you. A database holds a set of ideas, common themes, something. It's a file cabinet. So in that file cabinet, we might have everything about my life. We might have things about, you know, my teaching. We might have stuff about my student life, about my house insurance, about my car insurance. Okay, so the database would hold everything. It's all my Excel documents on a drive, on my USB drive. The schemas, you know, those that break into what tables I have, what views, and I'll cover views here in a second, what functions, kind of things like that. So maybe all my UNLV stuff. Then tables, those are the individual single Excel documents that I have. And they should be, or almost have to be, organized by rows and columns. There's a couple of terms real quick that I want to talk about. Indexes. All an index is, and is basically a way to organize a very large data set so you can find things faster. If I have all the classes I taught just in one big folder, you know, I mean, it's, you know, or let's say I have all my student classes, you know, I could have a lot of different classes. So let's say I just put them in there by number. 428, you know, 799, you know, 101. How do I know if I'm looking for Psych 101? I have like Biology 101 and one just, you know, it just says 101. And I have another class that says, you know, 101 number 2. It's hard to find things. So an index is like an encyclopedia where they kind of break everything down. A, B, C. Hey, I'm looking for something in C. I just go to it. So it's how we kind of organize and optimize things. Now a view is, hey, you know, I designed a query I designed a question, and I want to basically access that question right away. So it's a predefined search term or query that I can use. You know, I guess on older phones you had a speed dial, but you only have the first 9 digits on your phone. You know, 1 would call your best friend, number 2 maybe would call your mom. You know, you hit whatever, I don't even know how speed dial works. You hit like *3, and it dials maybe, I don't know, the pizza place. But you only have 9 of them. It's kind of the same way that views are. You know, you have a limited number of views, but a view does something that's already predefined. Let's continue. So, a data warehouse. A data warehouse is just basically a place where we move kind of a transactional database and we want to store it in some other place. We just take basically our cash register data, or maybe our text message data, whatever our data is front facing the customer, or whatever, you know, we're getting sensor data, and we move it somewhere else. Now, there's a couple different reasons for that. One, that now I can access that data and not worry about locking up my production machines. Maybe I have a cash register in Nevada and one in Colorado. They have different time zones, and I need to adjust for that time zone. If I want to know what my sales are at noon, well, I can't look at the same time zone in Nevada and Colorado and Mississippi. That's not going to work. They're different time zones. So what I might do is, well, and we'll talk about normalization a couple other terms down the road. I can take my cash register from each one of the states, and I can pull the data, and kind of extract it. I can transform it, i.e. shift the date or time, and load it to another warehouse or load it to another database, and make sure the time's all, I don't know, Central Time. Make sure it's all Greenwich Mean Time. You know, I can pick any time zone I want, but now I know that when I say 8 a.m., it's 8 a.m. at each store at each different location. So data source is basically where the data is coming from. Staging area is basically where I put the data before I actually load it, save it. You know, it's my scratch pad. It's my temp storage. Data storage is just where the actual data is stored. And the presentation layer, or the data presentation, is where like the analyst can access it. Now, diving a little bit more into this, there's kind of, I guess, 3 or 4 different terms. There's a database, which we talked about. It's kind of where the employee payroll database is, where the front-facing data is created, and at least conceptually. You know, a data mart. Now, a data mart is a kind of collection of databases, but with a very centralized theme. So if I had if I had multiple gas stations, my data mart might be, you know, all the cash registers that I own. So, you know, I saw a movie yesterday, the day before, and it said, hey, a Sony company. Well, you know, maybe Paramount is owned by Sony, so data mart might be all the Paramount movies. Now, Sony also sells TV, so I might have another sales data mart that just deals with sales. Now, Sony also deals with cameras, so I might have a third data mart that just has camera sales or camera information or firmware or whatever, you know, I want to store there. Then data warehouse is kind of more aggregated across all those data marts. Sometimes you don't have as much information, but you kind of, you know, aggregate bigger and bigger and bigger. Now there's a newer term, the last term is a data lake. And this is kind of an odd term because it goes almost against everything that we just kind of learned. So a data lake is basically you take all the database data and shove it somewhere to like a big data lake. And the reason is that sometimes in machine learning, you don't want aggregated data, you don't want processed data, you want the raw, just as vast amount of data as you can get. So that's often what the idea of a data lake is. Okay, so different theories. So trying to, again, explain this a little easier. The database is a filing cabinet in an office. You make sure it contains structured files like employee records, or maybe customer names, salary, for easy retrieval. A data mart is a specialized bookshelf in a library or dedicated to a book on a topic. So like if you see behind me, that bottom row is, I think, programming. That second row is mostly big data, okay? And that top row is genetics and medical stuff. So molecular cloning, drug discovery methods, pharmacology, can you say that? Drug discovery. So each one of my shelves is organized by a topic. Then a data warehouse is like a public library that has all different types of books. And then a data lake is just that holds various items in their original raw forms. Okay, so hopefully that kind of helps you conceptualize it, because it is kind of hard to understand this. And this is I never know if I should start off with this picture. This would be the last one. So data source, those are your OLTP, your transactional databases. Often, sometimes there are other things, but basically it's where you get your data from. In my last couple of examples, it is at the cash registers or the gas stations I own in Nevada, Colorado, and Mississippi or Florida, wherever. So each one of those is my different kind of, I don't know, cash register, vending machine, whatever. And I load it into some type of staging area. Now that staging area kind of can fix a date, can fix a time. Maybe one of them is using US dollars, maybe one of them is using pounds or euros, and it converts all to a standard format. And then my data mart, is a, like, this might just be all of my gas sales, all my gasoline information, how much I buy my gasoline for, how much I sell it for, how much I'm pumping it, how, are my gas pumps working or not. This might be all of my food sales. This might be all my Visa transactions. And then I kind of take certain parts of these and make one kind of warehouse, a data warehouse. And then individual users or people that want to seek knowledge, people that want to make more money, access either the individual data marts or the kind of data warehouse. Not the best graph, it's the best one I got. So now the why of data warehousing. So we like to look at, business today gets, I got a great picture of this, like 10 slides down. Nothing is simple anymore. At the end of the day, that's one of the big reasons of data warehousing. Nothing is simple today. So if I look at my phone, let's see if we see my phone here. So if I look at my phone, so let's think, we have my Apple ID, which has got to be one database, the apps I purchased, which is another database, then like my news stories from Apple, that's another database, my Apple Wallet, that's another database, my phone calls, that's another database, my text messaging, that's another database. So there's at least 5 or 10 different databases on my phone that somehow Apple or somebody has to kind of consolidate to start answering questions like, what is the most popular thing a phone does today? Is there a correlation between, hey, I get a text message and I call somebody? Do I buy something? Do I get a text message? Like we just got out of the political season. Do I just get a text message and then I make a campaign contribution? I mean, because there's a way we can track, hey, here's a message and then I load this app and then I send this money. So the only way to really do that is to have some type of big data warehouse, maybe a data mart if you kind of dig in a little bit more. But that's one of the main reasons, because data is all over the place and we have to join it to get intelligence out of it. Oops. Improved consistency, historical data tracking. Another thing too is at the end user where we get like messages and calls. I don't have my calls from 10 years ago. I don't have my calls from 1 year ago. I'm sure I could go to AT&T, sorry, and request all my call logs for the last year or two, and hopefully they'd give it to me. But they have a list of all my calls I've ever done in theory on my account. But my phone doesn't have that. Security and compliance, maybe you only want certain analysts to have certain access data levels. Integration with various data sources. Maybe one is MS SQL, one is MySQL. There are always little different things. So that's why we have data warehouses. Just text that nobody cares about. You can read that if you want. But I'm going to move on in 3, 2, 1. What else do we have? Now, data lake is kind of a relatively new term, maybe the last 5 years. Okay, So maybe I'm doing some kind of machine learning project and I don't want the data touched, or I don't want any changes. So let's say that I'm capturing the time or the temperature. You know, we made an analogy to temperature, and I captured every second on my digital thermometer, my outdoor thermometer. But when I actually go to put it on my web interface, I'm only capturing it every minute. I'm only aggregating it every minute. I take all the seconds of the minute, average temperature, and that's my daily, my minute temperature. So 10:01 a.m., it's 68 degrees. 10:02 a.m., 68 degrees. 10:03, 69 degrees. 10:04, 70 degrees. And that's extracted, transformed, and loaded data. That's manipulated data. Now, what if I want to do some type of machine learning project where I needed every second of data? That's where the data lake comes in. Generally, you just load kind of the raw data there. It's just a term. So let's keep going. Relationships. You know, how we hook up. So, there's a bunch of different ways to connect data. What do I mean by that? So I have 2 or 3 different Excel documents. How do I kind of copy and paste them together? Because if I delete one row, something it's just not going to work. So you have to really think, how am I going to join 2 rows, 3 rows, tables? How do I get all this stuff together? And so it's a really good question. So let's talk about relationships in terms of, this is a commonly called cardinality, but we can have a one-to-one relationship. So only maybe one phone number to one person. So on my phone, right now, there's a one-to-one relationship between a person's name, a contact, and their phone number. Now, one-to-many relationship. That may be when you're looking for Chick-fil-A. I can search for Chick-fil-A and it finds all the different Chick-fil-A's. One term, one keyword goes to many different restaurants. I pick what restaurant there is. You have a many-to-many and many-to-one. So, big idea. So now, in theory, when we look at an Excel table, when we look at an Excel document, when we look at an SQL document, okay, we have entities and attributes. What is an entity? A car is an entity. A person is an entity. Each column should be an attribute of that entity or that observation. I always like the word observation a little bit better. But if I have a red car, that would be a column. So I might have, like, you know, the VIN. That might be my identifier. And I have a red car. That would be an attribute. A Toyota would be an attribute. So those are attributes versus entities. They are properties of any characteristics of an entity. That's what an attribute is. So Richard Young has a phone number. He's a professor. He works. Those are all attributes of me. So when I design out my columns or my databases or my rows in Excel, I keep that in mind. Each row should be an entity. Each column should be an attribute. A couple more terms. So we have a primary key. That would be like the VIN. A VIN or some type of unique way to ensure that I'm only talking about that one particular thing. And when you have a key, when you have a primary key, no 2 primary keys can be the same. So in theory, my social security number is a primary key. My phone number is a primary key. So in other people's phones throughout the Vegas Valley, my phone number is a primary key that links to an attribute of my name. So we have all these primary keys that are unique. And they can't be the same as anything else. They can either be made up or they can be natural, unnatural, made up or derived, something else like that. You know, I have an NCID from UNLV, a university ID. It's a completely made up number. It relates to nothing but my university work. I have an employee number. That relates to nothing but my employee activity. And my employee activity only relates to me. My employee number, I should say. Now, my name, there's a lot of Richard Youngs in the world. That is not a primary key. So I'll show you an example, I think in a slide or two. In the customers table, the customer ID, not the customer name, the customer ID is a primary key. Now, a foreign key is how we link these tables together. It establishes a link between the phone number and maybe the name, between the customer and, in this example, the orders. Here we go like that. I have 3 Excel documents. I have a document of all my customers. I have an Excel document of all my orders. I have an Excel document of all the products I sell. How do I get to what customers bought what? Well, very simple. I take this primary key and join it here. And then I take this primary key, that's why they're both, and join it here to this foreign key. It's a relatively simple process, but until you start doing it, it's hard to conceptualize this. So now, in traditional databases, if I pull the, this book up and look up ETL, it will give me a completely different answer than what I'm going to explain to you. So I want you to kind of keep that in mind, because I want you to think like a business analyst. I want you to think like a data scientist, not like a database person, not like a database programmer anyways. Okay, so an ETL process, extract, transform, and load. Okay, and like I said, there is no document on Web Campus. But basically, I want to be able to grab the data from the database. I want to be able to transform it. So I want to get all my calls and see how many missed calls I have versus how many new calls I have. I want to see how many times my wife called me. I want to see how many times the university called me. I want to see how many times my boss called me. Then I have all that information. I want to load it into an Excel spreadsheet. I want to load it into Power BI. I want to do something with it. So that's a lot of what data is. We pull data, we transform it, which is a big word like summing or some type of analysis, and then we share it. This is kind of the way the class is. What would be the extract? That's your research project, the very first project you did. The transform, that's your analyze me assignments. Your load, that's your group teaching assignments. This concept is so important that's literally 90% of everything we do. If you're an accountant or you do accounting type stuff, you want to pull all the transactions. You want to do maybe a sum, maybe break it down by what's tax deductible, what's not tax deductible, and then present it to your clients. These are some common ETL tests. I'm not going to cover this. Do this slide. So now, it's funny, the one question I got wrong in my interview was normalization. I went with a statistical method and somebody meant this. So normalization is the idea that we can take data and break it down in a structured manner. So without normalization, I might have a whole address. Office of Admissions, 5445 Maryland Parkway, Las Vegas, Nevada. And think about this. Is this a Bart Simpson thing? It is. So I have a lot of data that's just repeated here and here and here. Okay? So if I had, hundreds of rows of this, it just takes up a lot of data. But now, if I can at least break up the department and the address. So one column is the department, the other one's an address. Now, when somebody needs to generate a letter, when somebody needs to do something, I just say, number 3 is Office of Admissions. So just, 3, boom, puts it in there. I only have it once. And the address is, the main address. So hit 1, boom, 31, and I have that whole address already done. I can even go a step further. I can break down the zip code. I can break down the city. And this saves time and energy. How many times have we gone to a website, and some of them, once in a great blue moon, you can enter your zip code and it knows the city and state you're in. Because that's just normalization. That's a well-designed system. Most of the time you have to type the city, then you have to type the state, then you type the zip. Why? because they don't normalize the data. It's an inefficient method. So, in their database, I can tell you they have hundreds of thousands of rows that say Santa Fe, New Mexico. They have hundreds of thousands of rows that say Boulder, Colorado. In theory, they just need to have one that says Boulder, Colorado is this zip code. It would save tons of space. So that's the idea of normalization, taking some type of big chunk of data and breaking it up to smaller parts. Here is a fun little website. You just go here, it does that. But instead of just typing the same thing, hey, Boulder, Colorado, Boulder, Colorado, Boulder, Colorado, every row, like I said, is there a better way to do this? Hey, I can say, hey, all the names, have a column with a bunch of names. Richard, John, Brock, Tom, Ron, just have all that in there. What's here, I can pick that in another column. Teach me, I could have that in another column. And then SQL, Python, I could just make this a very efficient statement. How could I break this up? There's a lot of wasted space here. So this is the graph I was talking about. This is, in theory, when we teach SQL and we teach databases, not in the real world, in academic environment, this is kind of how it looks.
That's not results. I'm sure that your coffee.
I'm going to have to turn off my Siri, but okay. So we have these transactional servers, transactional databases. And in theory, they get information from customers or sensor data, or, if you're maybe FedEx or trucks or whatever, we have customers. We kind of load it all up into a data warehouse, and we do our intelligence there. We have our data lake to save it, and maybe we move it up to a cloud, and then we push it into an app. That's beautiful. It's a beautiful design. The problem is it never looks like this. It never, ever looks like this. It always looks like this. It always looks like this. And when you have things that are this complicated, it becomes very hard to get data at the right place. This was for another demo project I worked on, but this is often how it is. And so this is, when I say all the easy projects, all the low-hanging fruit has already been taken, it's because everything looks like this nowadays. That's why, when I go into joins become important because of this graph right here. I have a whole other video on SQL, and I'm going to cover SQL, but I want to talk about NoSQL. That's not a root. So basically, one of the things about NoSQL or JSON or stateless APIs is that it's not like a traditional database. There's a lot of different ways to explain this, okay? But if I go to Google and type weather plus Las Vegas, there's a database somewhere that has all the major cities and all the weather. And I'm just basically doing a call to that database and getting it back. It can be kind of unstructured. It can kind of be different formats. But there are some APIs that are like RESTful and classless. And there's a bunch of terms. I just kind of want you to be aware that there's other things than just pure SQL to store data. There's NoSQL, and we use that a lot. But it's just, I use the word bridge, different systems allowing them to interact and share data. That might not always be necessarily the best row and column format. Okay, so what else? Yeah, stateless clients. So, not going to go into this. Now, here's a secret to life, or a secret to make a lot of money or something. If data is the new gold, which it is, I don't think many businesses, companies, or organizations will argue that. I need to find that stat that says, hey, startups that utilize their data are 80-90% more likely to succeed within the first year. There's all types of amazing statistics related to data usage. Companies that use data versus companies that don't use data. But the problem is we only use a small amount of that data. We only use 10% of that data, 20% of that data. So if data is so important, why don't we use 100% of our data? And it's a fair question. What happened at the bottom of my slide? A lot of the data that we need to address or need to deal with is not in rows and columns. At the end of the day, it's not in rows and columns. One second, let me see if I can pull up a picture. Hey, can you tell me the value of row 6 on here? What about column A, B? What does column B say? Well, Richard, that doesn't make any sense. There's no rows and columns here. I know it's a picture. So you're saying that this has no value? No, this is where the money is. This is the future of data, is unstructured data. Emails, this, ChatGPT interactions. And we're only using a small amount of our data. We're only using things that have been pre-formatted in rows and columns. And things like genomics, astronomy, medical imaging, none of that stuff fits in a database very well. X-rays, MRI, Tesla, the car driving videos. You think they have every second broken down to a car, to like a row? No. It's unstructured data. So unstructured data, and you can kind of store it in a database. There's certain things you can do, but it is super important for the future of business, the human race, everything, that we understand and we start attacking unstructured data, because 80-90% of the data in the world is unstructured. And so, like I said, even though SQL is super important, it's not always meant for a lot of these, not NoSQL, API, JSON. It's not meant for unstructured data for the most part, things like this. I have a little video treehouse, I don't know, whatever group, chapter 8, examples of unstructured value. Since most of the world's data is unstructured, an ability to analyze and act on it presents a big opportunity, and it's true. Very true. A lot of businesses are really focusing on unstructured data. And it's hard to imagine it, but if you have a big pile of papers on your desk, it's basically unstructured. You have pictures, if you saw my desk, it's a nightmare. I have papers from college, I have papers from school, I have research papers, I have UP plaques, I have everything, But yet, there has to be a rhyme or reason that I can find my data. Unstructured data is any data that doesn't fit neatly in traditional row and column formats, like you see in a spreadsheet or database. The data often doesn't have a predefined organizational format. Think of it as a pile of papers on a desk with different kinds of information. Some are pictures, some are handwritten notes, others might be printed documents. There's no single way to organize or for all that information. Now, granted, we've made huge strides in fixing this. We can take PDFs now and kind of convert them to text. We can take pictures and kind of figure out what's in that picture. We can take videos and kind of infer the motion of the video. There's a lot we can do. We can take x-rays and say, hey, does it have pneumonia? Does it have COVID? What is in this x-ray? So we're making progress on it, and that's going to be really big factors in the next couple of years of dealing with that unstructured data. Now, this is a horrible graph. I know that. But when I said at the very beginning, the very first slide, take it back home, get a database, get a free database and play with it. And I just want to show that there's hundreds of free databases. They all have different names, so don't get caught up on the name. So if we're looking at a transactional database, Amazon calls that RDS, where Azure calls it SQL database, where Google calls it Cloud SQL. They all call it slightly different things. If I'm looking for like a data mart or an analytical processing, an AP database, AWS might call that Redshift. Weird. They call it Synapse, BigQuery. Okay. If I'm looking for like what they call semi-structured or just key value pair, two different names. So don't get all caught up. Oh, well, I'm using RDS to do it. No. You're still using SQL. 90% of my SQL functions work on here. They'll work on here. They'll work on here. They'll work on any of these AWS functions. They'll work on Redshift. They'll work on BigQuery. Slightly different, but still, at the end of the day, it's very, very similar. There are a lot of different names for the products that we use, but it's still the same thing. I can drive a Toyota, a Nissan, Chevy, Ford. I can drive an EV or a combustion engine car. I can drive a Nissan NSX. I can drive a Ford Explorer. It depends how you bring it. Still the same idea. Now, granted, they're slightly different. I might not know how to drive the best of my ability or the best of the vehicle's ability, but I can still get around. I'll post some of these links here. I think that's it. So the next video is going to go into SQL in action. Have a great day. If you guys have questions, contact me, and thank you.